a DIY project for the Reynolds number. So this project will consist of first lab report and also the video, which is the experiment. Okay, this project, the first objective of this project is to determine the Reynolds number for the pipe for the different flow, which is the laminar and the turbulent. Then the things that we must include in the recorded video, which is the first introduction, objective, experimental procedure, which is included the pictures of the procedure that we do. Then lastly, it is conclusion. Next, this so for doing this experiment, we have 4 roles, which is planner, experimenter, analyst, and also the report writer. Since we have 3 members, I suggest the experimenter analyst will be the same person. Do you guys okay with that?
Yeah, I'm fine with that.
I'm okay with that.
So I will be the planner, and others?
I'll be the experimenter and analyst.
I will be the report writer.
Okay. So the task of the planner is divide the task, which is I'm doing right now, and plan the experiment and lead this discussion session. For experimenter analyst, which is Izati, she will explain the objective of the experiment and do the experiment. Analyst description task is to explain the introduction and conclusion of the experiment. For the report writer, which is Haikal, he will be doing the lab report and submit the report. So, do you guys watch the YouTube video?
Yes.
Okay, based on that video. Alright, thank you. Based on that video, is the procedure of the video is now I will tell you guys the apparatus that we need first. So
Okay.
there are 7 or 8 apparatus, which is rubber hose, die, syringe and needle, measuring jug, timer, and also transparent tube. So I will bring the rubber hose and die, and who will bring the syringe and needle?
I'll bring the syringe and needle.
I will buy the transparent tube and the measuring jug.
Measuring bottle or measuring jug.
Okay, both. Okay, anything.
Alright.
So I will explain the procedure of this experiment. First, we open the water tap and let the water flow through the rubber hose. And while the water flow, we will inject the ink in the transparent tube, and we will record the time for every 500 ml. And we will repeat the experiment this step with a slow and also the faster speed. And to get the average time, we will repeat for 3 times for each speed.
Alright.
So, okay.
Alright.
When we'll be doing the experiment? When are you guys free?
On this Thursday.
Okay. Haikal?
Can we do?
I think this Thursday will be suitable.
Okay, so we'll be doing the experiment on Thursday, and I hope you guys will be bring all the apparatus needed.
Okay. At what time?
Alright.
In the morning?
9:30.
9 a.m.
Okay,
Yeah,
9
around
to
that clock.
9:30. Okay.
Okay.
Okay, thank you guys. That's all
Alright.
for our discussion tonight.
Alright.
Thank you. Thank you, everyone.
Thank you.
Reynolds number plays an important role in observing fluid's behavior. It is used to determine whether a fluid is in laminar flow or turbulent flow. Reynolds number depends on several parameters such as diameter of pipe, fluid density, fluid viscosity, and average velocity of flow. The hypothesis of this experiment is time taken to fill up the measuring bottle with water increases as the Reynolds number decreases. So the equation that we use is NR equals to density multiply with initial velocity multiply with diameter divide by mu, and another equation is initial velocity multiply with diameter divide by final velocity. Fluids having Reynolds number smaller than 2 2000 is laminar because of its high viscosity and or low velocity. Fluids having Reynolds number bigger than 4000 is turbulent, typically due to high velocity and or low viscosity. Reynolds number bigger than 2300 but smaller than 4000 is transition. The objective of this experiment is to determine the Reynolds number for a pipe flow in different flow regimes, which are laminar and turbulent flow. So now I'll be explaining the procedure of this experiment. The rubber hose and transparent tube were attached to a tap. The transparent tube was injected by a needle syringe filled with coloring dye. A measuring bottle was placed under the transparent tube. The tap was opened at a low speed and the dye was injected. The flow types were observed with naked eye and the time for water to reach 500 ml in the bottle was recorded using timer. The experiment was repeated at least 3 times to get an average time value. Step 1 until 6 were repeated with full tap speed. The conclusion of this experiment is the flow of a fluid can be characterized to be laminar and turbulent. In a laminar flow, the motion of the fluid particles is orderly with particles are close to solid surface moving in straight lines parallel to that surface. The Reynolds number for laminar flow is below 2000. In turbulent flow, the motion is chaotic and lateral mix. The Reynolds number for turbulent flow is higher than 4000. In this experiment, the Reynolds number as a function of flow rate was determined. We found that as water flow rate increases, the Reynolds number also increases.